Thanks. So today I'll be talking, since this conference is titled Future of Web Apps, I'll be talking a bit about the future and about the next step in terms of web caching techniques. I have to start though with a short disclaimer, since this is the next step and not something you'll be doing when you go home tonight or tomorrow actually. So this is not something you'll be able to download today yet, but in the very, very near future. And I'll be mentioning PHP a lot, but whenever I mention PHP, you can think Perl or Python or .NET or Java. It doesn't really matter. The language doesn't matter. It's language agnostic, what I'm going to talk about. So quick introduction. My name is Wim Godden. If you want to follow me on Twitter, that's my Twitter handle. I'm from Belgium, best known for beer, of course, and chocolate and other very tasty, yummy things and odd-looking buildings. I'm from a very little town close to Antwerp, where we have a beautiful abbey, a couple of castles. Sadly, not all good news in Belgium. We also have a bit of traffic. This is what happens when we have some snow. And smack in the middle of that, I don't know what to call it, I founded a company 14 years ago. It's called Cube Solutions. We do a lot of PHP. We do a lot of scalability projects. We build a lot of internal apps, but also public-facing apps. I've been doing open source since around 1997, and I've worked on projects such as OpenX, which is an advertising solution, and then PHP compatibility, PHP consistent, and the thing that I'm going to talk about today. And I've been doing talks like these for the last couple of years. That's enough about me. Let's see who you are. Who is a developer? Okay, who's a front-end developer? Okay, it's about half. System or network engineers? Only one. Oh, I was going to say only one. That's weird. Any managers? Okay, a few. Okay, so I'm going to be talking about the next step. Now, in order to understand where we're heading, we need to understand where we are today. And in order to understand where we are today, we sort of need to understand where we come from. And I'm going to draw a little parallel between the web world and the written word. And I'm going to go way back for that. I'm going to go way back to the Stone Age. Now, if in the Stone Age you wanted to publish any news, you would do it a little bit like this. You would write on a wall, which is what we still do today. We still write on a wall on Facebook. So this would be the way you would publish news. Now, this is not a very portable way of doing it. If you want to share that news with some other caveman 2 kilometers further down, then you would have to physically go there and draw the whole thing again. But this is actually what we did in the old days. You know, we drew pictures. This is the Lego site back in 1996. It's a bunch of pictures glued together with some HTML 1.0, I guess. And this is what it would look like in Netscape 1 or Netscape 2. Yeah, basically just a bunch of pictures. And it doesn't really allow you to do any dynamic stuff. It's just visual representation. Now, of course, we had some progress. In the Egyptian era, we still have those pictograms. We still have drawings in there. We still have the bird and what else is there? The eye, and I don't know what they mean, but basically they're just representations of a certain meaning here. Now, there is a language behind it already, but again, if you want to basically copy the whole thing, if you want to share this news, you have to draw the whole thing again. And that's what we started doing in the early days of the dynamic web, where we would have a user connecting to a web server, that web server running a certain language, being it PHP or whatever, that language fetching information from the database or other sources and outputting it back to the user. But if the user presses refresh, that entire thing happens again, over and over again. So it's not really ideal. Let's move to the Industrial Revolution. We have a printing press. Very nice. We don't have to physically draw the whole thing again. We can just create a template, you know, those plates, and you can just put in paper, put in ink, and you get your entire page all at once. And this allows you to produce things over and over again, much quicker. And we started doing the same thing in the web. We started doing caching. We started caching things. So instead of going to that database every single time and fetching that data from the database using some query that takes way too long, we would fetch that data from the database and put it in initially in a file cache, in a local file system. And then when you hit refresh, you would just load that data from a file. And that would be a lot easier, a lot faster, and it would reduce the load on your database. Very nice. This is still a technique being used by a lot of sites, although file cache not being used that much anymore. Extra, the Hindenburg crashed, whatever. This is how people changed in the 1800s, how they changed newspapers. They would modify parts of that page. And in the web, we can do the same thing. Instead of having one cache file, we could split up that page and store the header and the footer separately and store the news separately. That way you can change only just one part of it. Now if you want to change the news, well, basically you change that in your database and you modify that news page. Again, you merge those together and you get your latest page, including that latest news. In the modern era, things evolved a little bit differently. Now we're watching television, and it doesn't really matter whether there's one person watching or 10 million, but it still matters in terms of infrastructure. If there's 10 million people who need to be connected, then you need the infrastructure to get cable there, or you need the transmission towers to send it wirelessly. So in the web, it's a similar story. If you get twice as many visitors, you're going to need a bigger infrastructure. So you're going to need more web servers. And this makes things a bit more complicated now, because you have people hitting that web server, going to the language, going to the database, or fetching those cache files. That's still the same. But now if we want to change something, then our admin user is going to connect, make a change in the database, but he's connected to one web server only. So he's going to make a change to that one cache file. And now there's a difference between the news on one server as opposed to the other server. So depending on which one you connect to, you get different information. That's not what we want. That was a problem about, I guess, 10 years ago. And people came up with a solution being memory caching. Yeah, you could say, oh, let's share those files on NFS, but that's not really efficient in the long run. So the ideal way to do this is to store information in a centralized system, decentralized across the network, like a memory cache. So you could have 10 servers that have a memory caching solution, and it will automatically spread out that information across those 10 servers, but you can update it from everywhere. So like Memcache is a good example, Redis is a good example, Couchbase, there's plenty of others. And so our admin can now simply update our database and push it to our Memcache, and that Memcache is available from all the servers. So you get the updates right away. Today, well, things are a bit different. We don't just watch the news anymore. We don't just browse the web when we're at home behind our desktop PC. No, we could be on a sandy beach and check our Twitter and our Facebook. We could be on the top of a mountain and be, reading blogs and so on. So we access the web all the time. We even get push notifications all the time. And that puts an enormous amount of load on our infrastructure. And you cannot keep adding more and more web servers with Perl and Python and all the other stuff behind it because it's just too expensive. So about 6 to 7 years ago, a lot of companies started adding something in front of their web servers. They started adding reverse proxies. And the goal was to cache all content that was repetitively being demanded to the web server. So any page that was requested from the web server over and over again, there was no point in having the web server rebuild it every time. So the goal was just to cut all those links and say, okay, we're just going to let the user communicate with the reverse proxy, and that reverse proxy is going to cache everything in memory. So does anyone know Varnish? A couple of users? Okay, so Varnish is one of the most used reverse proxy caches. It's very efficient. It's very fast, and I'm going to use it as an example first. So let's look at a typical website. This is just a sample structure. So a typical website might have a header and of course a footer somewhere, which might contain I don't know, the logo and maybe a login button and contact information, stuff like that. And you have a navigation structure, and you might have a block where you have the latest news, and then your actual content of a page. This is just an example of what a typical website could look. Now, that top header is not going to change a lot, so you might actually want to cache that part for 2 hours. And you might want to cache the left part for an hour, because it doesn't change a lot either. Now, the latest news, that changes a lot, so we only want to cache that for 2 minutes. And then the actual page content, maybe for 30 minutes. Now, if you want to do that in code, you're going to have to write a lot of code, and you're going to have to access that code every single time and check, oh, has this data changed? Do we need to update it? And so on. However, if you would do it in Varnish, there's a system called ESI, Edge Side Includes, that allows you to do this on the reverse proxy. And how it works is our user is going to request a certain page, /page, to Varnish. And Varnish will say, I don't know /page. I have no clue what it is. So let me ask the web server. And the web server is going to respond with a small piece of HTML code, which starts with an HTML tag, and maybe there's a head and a title and meta tags and body and so on. And then it says, ESI include source equals top. Now, if you send this to the browser will just ignore it because the browser doesn't know how to handle ESI tags. But Varnish luckily does, and it will see ESI include source equals top and say, oh, I need to go and fetch /top. So it's going to make a second request to /top, and the web server is going to reply, oh, /top, that's a div with a login link, nothing more than that. Now, Varnish will take this piece of code and put it exactly where that ESI include was. So you get this. And it will do the same thing for /nav and all the other stuff. And as you can see, there can be a div ID equals something. It doesn't really matter. It's still HTML, and Varnish will only interpret all the ESI tags. So in the end, you end up with a complete page. Now, just to be clear, for this first attempt to retrieve this page, you have /page going to the web server, and then an additional hit for /top, /nav, /latest news, and then the /article. That's 5 requests for one single page. But if you press refresh, everything's in memory. Every single block, every single ESI block is in memory. So he's not going to access the web server at all anymore. Only after 2 minutes, when that latest news in the cache has expired, it's going to hit the web server again just to fetch /latest news. And then another 2 minutes of nothing hitting the web server. So this is very nice, of course, because you're not hitting your web server anymore for any information that's in the cache. So you can cache anything that's static, so static HTML pages, images, JavaScript, CSS, fonts, anything that doesn't change a lot, and parts of a page using ESI. However, you can't cache post requests because those need to go to the web server, because post means make an update, and Varnish doesn't have any database connectivity or anything like that, so it sends all of those to the web server. It's not a file server, so I wouldn't use it to serve gigabytes of data. It's not really designed to do that. But then the biggest issue is it cannot handle anything with a cookie. In other words, anything that has user-specific content. If a user is logged in, Varnish doesn't know how to handle it. It will see that cookie and say, okay, I'm probably going to have to serve this person a page containing his wish list or his name or maybe the number of messages he has, something like that, or maybe his friends list. But Varnish doesn't know about that. It only knows about pages that don't have a cookie, that are identical for everyone. So whenever it sees a cookie, it's going to send a request to the web server. Now, if you have a site where people log in, then Varnish is basically pointless except for images, because every single request is still going to hit your web server. So when you have a page like this, where it says you are logged in as, and you have 5 messages, well, you could maybe cache that left navigation bar and maybe that content part if it's not user specific, but that top part will have a cache expiration of 0 seconds. So we hit a wall in our evolution here. And we hit this wall a while back, and there's a couple of solutions to this. Even in Varnish, you can have a solution where you can cache using specific parameters, and it will take the user ID into account, but it's very messy, all of it. And we had this issue back in 2010 with a customer where we wanted to cache information that was user-specific without actually having to go to the web server every time, but we couldn't find a solution. So luckily, we had an idea. And so instead of doing this, fetching /page from Varnish and Varnish connecting to the web server for user-specific content, and then the web server going to the database or fetching information from Memcache, we would just eliminate those and do that. So we're connecting our reverse proxy directly to our caching layer. Now, using Varnish? No, probably not. Anyone know Nginx? More people. Okay, very nice. So we decided to use Nginx. Nginx is a web server, very much like Apache and all the others, an Internet Information Server. But it's also a reverse proxy. So you put it in front of a web server, and it will do very similar things to Varnish and all the other reverse proxies. The difference is it's extremely lightweight and extremely fast, and it hardly uses any memory. Just to give you some idea, if you connect 10,000 times to Nginx simultaneously, you'll be using 2.5 megabytes of memory. If you try to do that on Apache, your server's going down. It's also the second largest web server in the world today. Only Apache is bigger. It's serving almost 15% of all websites. And for those of you who are very technical, it doesn't use any threads. It's event-driven. It doesn't block any connections. And it uses EPOL or KQ, depending on whether you're on Linux or BSD. And having 20,000 active connections and doing 20,000 requests per second is really very common on Nginx. So what we built back in 2011 is ESI on Nginx, but I should say it's not called ESI. In our implementation, it's called Slick. And this is how it works. So imagine you request /page for the very first time. Our cache is empty, there's nothing in there. Our user calls Nginx and says, give me /page. Nginx will say, I don't know /page. I have no recollection of ever having seen that. It's going to request whatever language you're running. And the language is going to return a page containing ESI, or in our case, Slick blocks, which are very similar. So they just contain Slick, include this part, and that part, and that part. Next thing it's going to do is it's going to store that definition of those blocks in internal memory. So now he knows /page contains these blocks. And he's going to push that to Memcached. So now it's available to all the Nginx servers on the network. Then, of course, he doesn't know what to serve to the user yet because he only has the block definition. He still needs the content of those blocks. So he's going to request the web server for /menu, /news, and then /top, that top part where it said you have 5 messages and you are logged in as. And he's going to use the session for that because that user is logged in. So he's just going to send the cookie along. So the web server will return, you are logged in as, you have 5 messages. And he's going to store that information in Memcache using specific session information. Now if I press refresh, Nginx is going to say, /page, I know /page. I have that in my memory. I know it contains these blocks. And it's just going to fetch all of that information from Memcache and serve it directly to the user. We're not hitting any language. We're not processing any code at this point. So what does it look like? Well, it's very similar. It just says slick include, source equals something, except that there's an additional attribute here. It's called key, which is the key we use in our Memcache request in the caching layer. And then for anything that's session specific, at the top it will say session equals true, meaning store this for logged in users specifically. Now you might wonder, wait a second, what happens if you have 5 messages if one of you sends me a message? Well, it should say you have 6 messages, right? But how do I get that? Well, sending me a message is still a post. A post will still go to the web server. Nginx will just say, okay, I'm not doing anything with this, I'm passing this along to the web server. Now, instead of just storing that in the database, which you should, of course, you can just update that message count in memcached from your code. Now if I press refresh, I see you have 6 messages instead of 5. And you use that same session ID. So the advantage of this is you get no repeated get hits to your web server. Any information that's in the cache will be served from cache. Any information that's not in the cache, of course, you will retrieve it from the web server and then push it to the cache. What you can do actually is when someone logs in, that's a post, because you need to verify username and password, you can actually warm up the cache so you can load their favorites and their friends list and how many messages they have and just push it into the cache. Now when they go to the next page, everything is in the cache and everything is served from the cache. You're not hitting your web server anymore. So no repeated hits for user-specific content, but you can actually do it for non-specific content, like the news. Say, for example, we add news. That's a piece of code. That's a post. Your admin will do that, probably, someone maintaining the news. Well, just push it to memcached right away. Now, instead of having to delete that part in the cache, you're just pushing it to the cache. Someone hits refresh, he gets the latest news right away. So how many memcached requests do you think this page has? Any idea? Any guesses? How many times do we need to fetch something from memcached? 3? It's actually 1. So the advantage of using a caching layer like memcached is you can fetch all of the information in one go. If you know in advance which blocks you will need, you can just make one call to memcached and fetch all the information simultaneously. Even if it's spread out across multiple servers, it's going to fetch all of those at once and get them all. Which means that you could, of course, end up in a situation where there's 3 of them in cache and 1 of them is not. But then Slick will handle that and fetch the remaining 1. Now, I said before it was called ESI. So our first release that we did back in 2011 was based on the ESI specification. But we ran into a little bit of an issue with that customer. And although they promised we would be allowed to release it as open source, they did not honor that deal. So we ended up developing something that we could not release. So we told them, look, okay, fine, we'll start from scratch. We'll rebuild it in a much better way as well. And so that's what Slick is. So within Slick, you can do more than just include stuff. For example, if you are an administrator, you could have an if statement in there that says, if this person is logged in and he is an administrator, then show that piece of code. Then show this HTML. Show this button because the admin is allowed to click on that button. So you have if, else, switch case, for each, and stuff like that. There's exception handling in there as well. So you can have a lot of different things. I'm going to give you a small example of code. I hope it's readable at the back. So for example, you are logged in as, and then it says Slick session variable person name. And it will just get person name for this specific user from the cache and replace that part. There's also a short version if you don't want to type too much. This is a switch case, so Slick switch, and we're going to check if that person is an admin. So the session variable is admin. And we're going to check, if the value is 1, then we include admin buttons. In any other case, then we include, a div. There's a div in there. It's still HTML. And then we include other buttons, user buttons. And you can have a for each. This one's more complicated. You can have a for each, for example, if you have a discussion thread and you have multiple posts in there, you can include those all at once, and it will just load all of that information and for each across it. So there's a couple of ways, for example, to build this system. Now, you could have code like this that says, it's you are logged in as, and then we show the person name, and you have 5 messages. But in this case, you have 5 messages is specific to me. So I would have to store that entire block as top_31, if my user ID is 31. And then I would have to do that for every single user in the entire system, which is not really efficient. If I have 10,000 users, I'm going to have to store 10,000 top blocks. So a more efficient way would be to replace that you have 5 messages by you have session variable messages. And now it's going to be the same for everyone. I only have to store 1 top block and he's going to automatically put in the right number of messages. And actually in this, in the Slick version, we also added JSON support, so you can actually store the whole thing as user data and just have an array in there that has person name and favorites and all of those things, and it will automatically fetch all of that out. So you might wonder, how do we identify the user? Because all we're passing as a visitor to a site is a session cookie. So all you need to do is configure in the Nginx configuration 2 parameters. There's the session cookie name and there's the session identifier. So for example, in PHP it would be PHP sesID, which would be the name of the cookie that you're sending along. And then the identifier could be whatever you want. In this case, let's take user ID. And then if the user visits a page, he's going to send along his cookie if he's logged in. That cookie was set on login. And Slick is just going to say, okay, I'm going to get user ID underscore and then that cookie contents. And it's going to get back, like, for example, 432, which is my internal user ID. And then I can fetch any information that's linked to me. So for example, I can fetch user data underscore 432. Why did we select Nginx? Maybe I need to explain that quickly, because Varnish had ESI support, so why go for Nginx? Well, a couple of reasons. First of all, Nginx had native memcache support. Now we don't use it anymore in this version, but we used to. But most importantly, it has a super fast sub-request system. So if you have 20 Slick include blocks, each one of those will fire up a separate sub-request, and they will run in parallel, which means that it's super fast. You can use multiple cores on your CPU, and it will just be incredibly fast. And it can handle thousands of connections at the same time and hardly use any memory, which is a very nice thing to have as well, of course. For us, because we use PHP a lot, it integrates with PHP FPM, which allowed us to do like slow request logging, and we could do offline processing and stuff like that. So what's the result? I'm going to show a little graph from the second customer where we implemented it. This is the average load on their web and database servers when you enable it. And the reason it drops like this is because we are not actually hitting the web server anymore. We're not doing any GET requests to the web server, which means we're also not doing any calls to the database. So this is purely post requests and maybe a few GET requests where we missed something while re-implementing the thing. So we actually took them from 87 to 12 machines. And then we had another customer where we did the installation on the test platform, and they did the production release, and they went from 1,300 and something to almost 400 servers. And that's just because the number of GET requests is so reduced, because that entire layer of web processing in whatever language you're using is just cut out completely. I want to give a short example. Does anyone know vBulletin? A couple of people. So vBulletin is discussion forum software. We had a customer who had a big forum with 12 million posts, and they were experiencing some load, and we wanted to just test to see what we could do with Slick. And so this is what a standard discussion thread would look like. You see there's a couple of posts. Those would be Slick includes within a for each. And then there's information like at the bottom there's some buttons. Well, we would just check if that person is a moderator on the discussion forum, and if he is, we show those. And the same thing for that part, which is just in the isAdmin session variable. So this entire thing is one big template that's identical for everyone. We don't have to change anything. For moderators or admins, it's perfectly identical, and it will just automatically load all the data from the cache, just fill it in, and serve the page. The result is that if you look at web and database server load, the first two is vBulletin, basic install, and then vBulletin with memcache support, because they have some built-in memcache support. And then the third one is with Slick, and you see the load drop because we're not hitting that database, we're not hitting the web server every single time. Of Of course, we want to see how far can we push the system. So if you take 1 being 282 requests per second, that's the maximum we got out of a vBulletin installation, then that's what you get, just because you're only hitting that reverse proxy cache, and you're not going to process any PHP code behind it. Now, of course, to get there, you need to change code. You cannot take a website, install this thing, and expect it to magically do this for you. So first thing you need to do is you need to make changes in your template, in whatever HTML you're outputting. But luckily, those changes are quite minimal. It's like when you have a for each now in your code because you need to loop over something, well, you just need to replace it by slick for each. If you have an if statement now, you just replace it with slick if. So those changes are quite minimal. The biggest change is that whenever you have a post and you write something to the database, now you have to write it to the database and update it in the cache right away. If you forget to do that, then the user will be served old information. There's 2 ways of doing that. If the user is logged in, well, you need to push the update to the cache. You have no choice. If the user is not logged in, you can also do that, but you could also wait until they log in and then warm up the cache. It just depends on how much information you actually need to have available to your users. So, anyone interested in using this? Couple of people, yeah, okay, good. I have good news and bad news. So the good news is, yes, it's going to become open source. That's the reason why we started rewriting it. And the concept is solid. We've tried it at 4 customers. It works very well. The bad news is, as I mentioned, the original version, yeah, we can't release that because of copyright issues. So we're rebuilding it completely. And then we're going to open source it. And, well, we don't have any current customers for it to implement it for, so this is a spare time project, which means it takes a lot longer than we would like, because we simply don't have the budget to just put someone on it full time. Of course, if someone feels like sponsoring us, then let me know. Nevertheless, we expect to have a beta out on GitHub probably somewhere in October, probably around the Nginx conference next month. And then, depending on how much time and money we can spend on this, we should have a stable release somewhere beginning of next year. So, we started, well actually this is even before the Stone Age. So we started in the Stone Age, we moved ahead a little bit, and I hope I was able to show you a little bit of where we think, well, we're heading. Any questions?